Good evening to all. Today we are going to discuss on the topic AI based charging, demand forecasting and scheduling. Along with that one we are going to discuss about V2G integration for grid stability. V2G means vehicle to grid. First, in the last class, we have discussed on what is smart charging, introduction to smart charging and its types, and how smart charging is going to be managed. That is by the mean of energy management. And there are different types of techniques for the smart charging. That is peak shaving, shifting, and load balancing. In the load balancing, also different types of strategies we have discussed. So now we are moving on AI based charging demand forecasting and scheduling. What is meant by forecasting and scheduling? General meaning of forecasting and scheduling. Can anybody tell? Anybody?
ಫ್ಯೂಚರ್ ಇವೆಂಟ್ನ ಪ್ರಿಡಿಕ್ಟ್ ಮಾಡೋದನ್ನ ಫೋರ್ಕಾಸ್ಟಿಂಗ್ ಅಂತೀವಿ.
Very good. Then scheduling,
ಪ್ಲಾನಿಂಗ್ ಅಂತ.
planning. Okay, with respect to electric vehicle, the forecasting and scheduling is nothing but in the future what is going to be happen. That is, we cannot forecast to without knowing the history. ಹೌದಾ? Without knowing the history, we cannot what is going to be happen in the future. We cannot predict that one. That is a predicting of what is going to be happen. What that is nothing but the forecasting and scheduling by knowing the future trend or future power demand or power sharing and the supply from the grid. Regarding these things, if we know those things, then we can schedule the which how many electric vehicle are going to be come for the charging and which time they are coming at on which day of which time of the day the number of vehicles are more, on which day of the day number of vehicles are less for the charging purpose. That is nothing but the forecasting and scheduling accordingly. So which is for the peak period how it should be, for the off peak period how it should be, in the morning how it should be, how it will, how what is the demand in the morning, what is the demand in the afternoon, what is the demand in the peak hours, what is the demand at the late night, late 10 p.m. So that is nothing but the forecasting and scheduling accordingly. The how many chargers are there in the substation, how many vehicles are coming, and how can we allocate the uh, power for each electric vehicle. That is nothing but the scheduling. So that is general meaning of forecasting and scheduling, and that is done by an artificial intelligence. Then it is called as artificial based charging demand forecasting and scheduling. If we do manually it takes lot of time, so it is not possible to predict. We can run just on the book we can note down um, June on the month of June 1st, 2026, how many vehicles have come, how many, what is the capacity of the battery, and what is the SOC. So if the number of vehicles are very less, one or two, we can note down everything. But if the number of vehicles are in terms of hundreds, 200s, 300, 400s, then it is very impossible. It is highly impossible to predict the note down the readings and the data and everything from the customer side and far from the user side. So note downing is a very tedious thing. It is not possible. So how can we do this forecasting and scheduling? So the best way is to have the AI, artificial intelligence techniques or AI based techniques to forecast the demand, charging demand and scheduling. That is the one way. So the most in the most of the all the cases and the applications, either it may be electrical, it may be electronics, or it may be any computer science background or anything. So AI is the basic thing that can be done all the activities without the interpretation of human beings. So that is the one very advanced technology what we have presently. So that is nothing but the artificial intelligence. By using that one we can forecast the demand and accordingly we can schedule the power allocation. So that is how AI can be done. So that is introduction part. So it should be a smart charging and artificial intelligence, and it can the AI can be done the energy management, and also it can build the EV infrastructure as our requirement. So how AI perform EV charging, demand forecasting, and scheduling. AI performs EV charging demand forecasting and smart charging scheduling in two consecutive stages. First, it predicts how much charge demand will occur. Then it decides when and how each EV should be charged to reduce the cost and avoiding overloading of the grid. So in the two different stages, this AI will do its job. In the first stage, it predicts how much charging demand will occur. So in the past history of 1 month, how we are going to and how we do the programming, how the data is going to be given for the AI. So that is nothing. That history will be stored. So from the history, it is going to be calculate the how much charging demand will be occur in the tomorrow or day after tomorrow at the now or after 1 hour or after 2 hour. So it is going to predict that charging demand in the future, and also it decides how when and how each EV should be charged and reduce with the reduced cost and avoid the overloading the grid. In the yesterday class we have discussed that uh, our the main interpretation of doing the smart grid is to from the conventional smart charging from the conventional charging is to reduce the stress on the grid. First point. Second point, to reduce the overload on the transformer. Third point, to reduce the voltage drop. Yeah, and the fourth one is to benefit the user, that is to reduce the cost. These are the 4 points that are the main objectives of going for the smart charging rather than the conventional charging. Remember, in the last class we have discussed these 4 points. Only beyond for these points, one is how to reduce the stress on the uh, grid side. Second one is the how to reduce the overload on the transformer. Third one is the how to reduce the voltage drop, and the fourth one is uh, that is reducing the cost or benefiting to the customer. So these four parameters are very important when we are going with the smart charger. So here also A will do the same thing. It predict how much demand will occur and also how to charge the vehicle and to avoid the overload of the grid. These 2 points are many very important tasks done by the artificial intelligence. So this is the framework that is allocated for the AI, artificial intelligence. It do the first. Without the data, AI will not do anything. Remember, if AI is to perform, we need to give the data. When we give the data, it will fetch the data and accordingly we perform its tasks. Without data, no AI. So first we will take the historical data and it process the data, and is based upon the historical data. After processing, it selects the what future in the future what is going to be happen, and which selection we need to consider. That means among the different types of EV charging, or among the different types of battery capacity, how can we select the chargers. So that is future selection. Then we need to train the AI model, and it will calculate the demand forecasting, and also accordingly demand forecasting, it will schedule the smart charging and then charging the commands to the EV chargers, and then monitoring and feedback. This is the process involved in the AI based EV charging. First, historical data, then processing the data and selection of future, and then training the AI model, and then charging the demand forecasting, then charging the smart charging the scheduling, and then charging the commands to EV chargers, and then monitoring and feedback. This is the framework. So first step in the AI based EV charging framework, the first step is historical data collection. In the historical data collection, what is going to do by the AI? First, the AI collects the data from the various sources such as EV charging history, arrival and departure time of the electric vehicle. EV charging history means how much in the per day, if it is a, today is the 13th and the 12th day and on 12th July, how many chargers are, how many vehicles are came for the charging, what is the capacity of the battery that is going to be charged in the last day, that is on 12th. How many chargers are, how many vehicles on the morning, how many vehicles on the afternoon, how many vehicles are on the evening or post evening. So that is, that data is going to collect from the AI. So then out what time they have arrived and what time they have departed. So that is nothing but the charging time, how much charging time is taken by the electric vehicle 1 and 2 3 rest. Then state of charge, whether they have come with the state of charge 20% or 30% or 40% or the 0%, and how much capacity they want, either the 90%, 85% or 100% they want. So both the initial charge and the final state of charge both are calculated. Then historical prices, sorry, electricity prices. So when they come for the electricity charging their electric vehicle, how much prices they have taken, how much prices are they allocated to each charger. And weather condition, whether it is a rainy condition, whether it is a wind cloudy condition, or it may be a very high temperature, and those temperature condition will be taken from the history. And the day of the week and holidays, so whether it is on the Sunday or the whether it is in the weekend days or the weekdays or holidays. So in the holidays, whether the more number of vehicles come for the charging on the holidays, or more number of vehicles come for on the government holidays, or more number of vehicles come on the first day of the week or middle day of the week or end of the week. So that is that data will take fetch from the history by the AI. And building load, and building load will be the constant, almost it is a constant, it is not variable. So that building load and renewable energy generation, along with the history, along with the history of the vehicles and the vehicle charging, it also collect the data from the renewable energy. So that means, so the power, it is not only the power supplies from the KEB or KPTCL or any government sectors, or also it from that is whatever the power generation from the idle thermal or nuclear. It also take the any renewable weak any renewable energy plant that is connected to the charging station, that data is also collected, either it may be solar or it may be wind generation. First, first step is historical data collection. Next is going to be process the data, whatever the data that is collected, that is going to be processed. So the collected data is cleaned and prepared by removing missing values, removing incorrect data, normalizing the data, converting data stamps timestamps into the useful features, that is hour, weekday and seasons. So the data what we what AI fetch from the previous days or previous months, it is not exactly whatever exactly not correct all the time. So it is going to be it is going to be tune those data and get remove the incorrect data and removing the missing values also, and we to normalize the every data that is collected, then convert that into the useful features, or it may be in terms of minutes or hours or weekdays or seasons. Third step is a future selection. AI select the most important parameters affecting charging demand at maybe a time of the day, number of connected EVs, initial state of charge, required charging energy, electricity tariff, temperature, building load, solar PV output. So future whatever the data is collected, that according to that one it is going to be select the future parameters, and it train the AI model. So different AI models can be trained using historical data, using artificial neural network, that is ANN, long short term memory LSTM, GRU, random forest, XGBoost, support vector regression. Not only these techniques, any other techniques they can train. By using any technique, it going to be AI can be trained. So only few techniques that are shown here. Then charging demand forecasting. The trained AI predicts number of electric vehicle expected, total charging energy, peak charging time, charging power demand. So once in the first step, it history data from the history it will be connected, then that is going to be processed, then that is going to be select the future, and then it trains the model using any of the technique, and then it forecasts the demand, charging demand. So depending on from the first step to fourth step, it is going to do the initial work, and then it is going to be forecast the demand, charging demand. That is how many number of electrical vehicles are expected in the next day, or in the next week, or in the next month. Then total charging capacity. So depending upon the history, it is going to be predict the for our forecast the next, what is the total energy capacity of the vehicles that are coming in the next tomorrow, or day after tomorrow, or next week, and what is the charging time, whether it is in the morning, or in the afternoon, or in the evening, or at the night. So it is going to be predict the peak charging time, and also charging power demand in terms of kilowatt also it is going to be predict. So AI, the finally whatever it is data, it is collected, fetched, and processed, and using the any tool or any technique, it is going to be it's going to be forecast the future, what is going to be there. So on these four number of electric vehicles are expected, total charging energy, peak charging energy, and charging power demand. So in the next step, smart charging scheduling. First, it will going to be forecast. According to the forecast data, it is going to be scheduled the charging. So using the forecast, an optimization algorithm scheduled charging by considering electric vehicle owner's departure time, battery SOC, electricity price, grid load, transformer capacity, solar PV availability, and now the scheduler will decide which EV to charge first, charging time, start time, and which EV to charge first, charging start time, charging duration, and charging power level. So smart charging scheduling, it is going to be scheduled the things by knowing EV owner's departure time, battery SOC, electricity price at the morning, or in the afternoon, or in the evening, and the transformer capacity during this time, and also solar PV availability, whether the availability solar PV available in the during only daytime, in the night time we don't get any sunrise to generate the power. So by knowing this one, so schedule it, the AI going to be decides which EV is to charge first, charging to start when it is to be started, and how much time it is going to be we need to charge the electric vehicle, and the power level. So these things is going to be scheduled by the AI. For example, suppose 5 electric vehicles arrive at 9 a.m. Grid limit is 50 kilowatt. Each electric vehicle requests for 20 kilowatt. See, suppose 5 electric vehicles arrive at 9 a.m. Grid limit is 50 kilowatt. Each EV requests for 20 kilowatt. Without scheduling, total demand is 100 kilowatt. See the example. Can somebody call to them? No, only few members are joined. Mamta, can you call to Achar or anybody? Sneha, you call to anyone?
Yes, sir.
Informed? Did you inform
Yes, sir.
what they said?
ಜಾಯಿನ್ ಆಗ್ತಾರೆ ಅಂತ ಹೇಳಿದ್ರು ಸರ್.
ಯಾರಿಗ ಎಲ್ಲರಿಗೂ ಕಾಲ್ ಮಾಡಿದ್ರಾ?
ಇಲ್ಲ, ಸಲ್ಮಾನಿಗೆ ಕಾಲ್ ಮಾಡಿದೆ ಸರ್, ಮತ್ತೆ ಇವರು ರಶ್ಮಿ ಅವ್ರಿಗೆ ಕಾಲ್ ಮಾಡಿದೆ. ರಶ್ಮಿ ಅವ್ರು ಪಿಕ್ ಮಾಡಿಲ್ಲ ಸರ್.
ಪಿಕ್ ಮಾಡಲಿಲ್ಲ. ಮಮತಾ ನೀವು ಕಾಲ್ ಮಾಡಿದ್ರಾ?
ಸರ್
ಅದೇ
ಮಮತಾ
ರೆಸ್ಪಾನ್ಸ್ ಮಾಡ್ತಿಲ್ಲ ಸರ್.
ರೆಸ್ಪಾಂಡ್ ಮಾಡ್ತಾ ಇಲ್ಲ.
ಹಾಂ ಸರ್.
Okay. Now, for example, there are five electric vehicles arrive at 9 a.m. In the morning, there are five vehicles come to the charging station. Consider at the 9 a.m. the grid limit is 50 kilowatt. At 9 a.m., five electric vehicles come to for the charging station. At that point, the grid limit is only 50 kilowatts. That means it is only can supply it only 50 kilowatt, not more than the 50 kilowatt. Maximum is the 50 kilowatt. When five vehicles come for the charging, each electric vehicle requests for the 20 kilowatt. Each electric vehicle request for the 20 kilowatts. 20 kilowatts. What you will do? ಏನು ಮಾಡ್ತೀರಾ ಸ್ನೇಹ ನೀವು ಅವಾಗ? There are five electric vehicles come for the charging. Grid capacity is 50 kilowatt. There are five charging points at the charging station. Each electric vehicle requests for the 20 kilowatt. What you will do?
ಇಮಿಡಿಯೇಟ್ ಚಾರ್ಜಿಂಗ್ ಯಾವ ವೆಹಿಕಲಿಗೆ ಬೇಕೋ ಅದನ್ನು ಚಾರ್ಜ್ ಮಾಡ್ತೀವಿ ಸರ್ ಫಸ್ಟ್.
All are all they want. I have the emergency. I need to charge.
ಎಲ್ಲದಕ್ಕೂ ಈಕ್ವಲ್ ಆಗಿ ಚಾರ್ಜ್ನ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಮಾಡೋಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತೀವಿ ಸರ್.
If you do that thing, then the time taken to reach the 20 kilowatt is very long time. It will take very long time. So that's how AI will do. What AI will do? See here, there are two options. One option is they can wait for the long time. Other option, we can, as you said, you can power allocation equally. In the last class we discussed on allocate the power equally. That is the one method. So second method, A can do the scheduling. It is with respect to the scheduling. So EV1 and EV2 charge immediately, it becomes 40 kilowatt. So EV3 starts at 10 a.m. and EV4 will start at 11 a.m. and EV5 charges when solar generation increases. Obviously above after 11 a.m. the intensity of the solar rays will be high. So it is not going to be. See, what you say, that is also correct, but you are not think of history. ಹಿಂದ್ಗಡೆಯಿಂದ ಡಾಟಾ ನೀವೇನು ಯೋಚನೆ ಮಾಡಿಲ್ಲ. ಅಟ್ ಪ್ರೆಸೆಂಟ್ ಟೈಮಲ್ಲಿ ನಮಗೆ ಏನು ಮನಸ್ಸಿಗೆ ಹೊಡಿತೋ ಅದನ್ನ ನಾವು ಮಾಡಿದ್ವಿ ಅಷ್ಟೇನೆ. ಬಟ್ ವಾಟ್ ಎ ವಿಲ್ ಡೂ? ಎ ವಿಲ್ ಟೇಕ್ ಫೆಚ್ ದ historical data, history data, previous data will take and process and then finalize the scheduling. So according to that one, this is the final outcome. Because AI is nothing but the tool. It will take the data, fetch and run and then execute. So according to that one, the scheduling with the AI will become like this. First to AV1 and EV2 charge will be immediately, then each one require 20 kilowatts, then total to 40 kilowatts. EV3 starts at 10 a.m. So At 9 a.m. almost if it is a DC fast charging, almost 50% of the charging will be over. So at EV3 starts at 10 a.m. and EV4 starts at 11 a.m. EV1 and either EV1 and EV2 are get fully charged or required to their SOC level. Then EV5 will charge according to the depending upon the renewable energy. So this keeps load below the grid limit while ensuring all EVs are charged before the departure. So this is the what AI will do. So then why we need forecasting? So we need a forecasting because we have some challenges. So increasing EV penetration, because in nowadays in the road there are more number of electric vehicles are running. So that is the one thing, increasing the EV penetration. Because in the what we do in the petrol bunk or diesel link, within the short span, within 1 minute or 2 minutes of waiting period, we can complete our fuel tank and we can leave the station. But it doesn't happen in the EV charging, because EV charging takes much time. If it is a DC charging, it will take around of 30 minutes. If it is a AC charging, it will take hours together. So there are more electric vehicles, so we need to go for the AA. But it is not in the case of it is not necessary in the case of IC engine vehicle or power station, this petrol or diesel stations, diesel petrol bunks. And also peak demand is very important when more number of charging electric vehicles are going to be come for the station for the charging purpose, and the transformer overloading, and also renewable integration. So these things we have discussed in the last classes. The same challenges are there. That's why we need charging forecasting. Then what is charging demand forecasting? So for these challenges, we need to go for the forecasting. So then what it is? Actually, it estimates the future demand t plus 1. So at t is equal to 0 is the present day. Present. What we are at the t is nothing but we have now what is at present. T plus 1 at in the future, at maybe in a 1 hour later or 2 hour later or 3 hour later, how many electric vehicle are going to be arrive for the charging, that is going to be estimated. That is nothing but the forecasting estimation with using historical data, and it will use the output in terms of kilowatt energy demand, number of electric vehicles that are going to be arrival, and the charging duration and peak load. So that will predicted by the AI. That is nothing but the forecasting. Then why AI for forecasting? Artificial intelligence for forecasting. The conventional methods are statically averages and regression. So limitations are non-linear behavior, and it is a linear. So these conventional methods only adapt for the applicable for the linear loads, linear, but it is not for applicable for the non-linear charging patterns. So the AI will do, it learns the pattern historically from the history, and adapt self adaptation, and then high accuracy. So smart charging framework, the components are required are EV users, how many EV users are there, and then charging stations, how many charging stations are there, cloud server, AI forecasting engine, scheduler, and utility grid. So forecasting horizon may be a short term, or it may be mid term or long term. That means only it is going to be forecast for the next what happens in the next minute, or what is the uh, prediction level in the next hour, or it is called as short term. ಶಾರ್ಟ್ ಟರ್ಮ್ ಅಲ್ಲಿ ಅಂದ್ರೆ ನೆಕ್ಸ್ಟ್ 1 ಅವರ್ ಆದ್ಮೇಲೆ ಎಷ್ಟು ವೆಹಿಕಲ್ಸ್ ಬರ್ಬೋದು, ಎಷ್ಟು ಕೆಪಾಸಿಟಿ ವೆಹಿಕಲ್ಸ್ ಬರ್ಬೋದು, ಎಷ್ಟು ಡಿಮ್ಯಾಂಡ್ ಬರ್ಬೋದು ಅನ್ನೋದು ಚೆಕ್ ಮಾಡೋದು. That is minutes to the hours. Second is the medium term. Medium term ಅಂದ್ರೆ it will forecast the it will forecast for the next days to week. After 1 week or after 2 weeks, after 3 weeks, how much capacity is required, how many charging capacity is required, that is going to be calculated. Or it may be a long term, months to years it may take. It may forecast the demand for the months to years, then it is called as long term. So forecasting may be in the short term or medium term or long term. The objectives why we need to forecast the charging: to predict EV arrival rate, how many electric vehicles are arriving at the particular time, charging power demand, how much power demand is required at that point, and it may be, as I said, whole day or whole week or whole month or in the future of year, that may be predicted by the AI. And station occupancy, and then grid loading, how much grid is have the load, how much grid is supplying the power to the charging station. So to predict all these four values we need forecasting, that is done by the AI. So then what data sources we need to do, we need to have to collect this information, that may be a forecasting or it may be for the scheduling. The data sources are, we need to have smart meters, we need to have the charging stations, weather data we need to have, traffic information we need to have, and electricity prices we need to have to predict and to give the scheduling for the charging. All these sources we need to have. So this is the AI based smart charging architecture. Once go through this architecture. AI based smart charging architecture. So there are five steps involved in the AI based smart charging architecture. First is input data, second is pre-processing, third one is the AI model, fourth one is the demand forecast, and fifth one is the scheduling the engine or scheduling the electric vehicle you can call. So what is the input data? EV electric vehicle and a charger data is going to be collected. Grid data, that is the how much capacity, how much power is going to be taken from the grid, that is collected. Renew, if there are any solar or any wind energy we are taking from the plants, we need to take, it will take that data. And user preferences and pricing, that is user going to be prefer in the for the low price or the for the high price also, or it may be a slow charging or it is a fast charging. That preference from the user will be collected. And historical data it is going to be used, and weather data it is going to be collected. So that is the six different types of data it is going to be taken from the AI. One is the electric vehicle and charger data, grid data, renewable energy data, user preference and pricing, historical data, and weather data. After taking that one, it is going to be go for the next one, pre-processing. That is data cleaning, any missing or unmatched data is there or wrong data is there, that is going to be cleaned. That is a missing value handling, and normalizing the data, and future extraction and data transformation. So once it take the in data from the input side, it is going to be clean the missing values or wrong values, and normalizing the and formatting the all the data in the proper way. And it going to be according from that data, in the historical data it is going to fetch, you can going to predict the future information, and then that data is going to be transferred. That data is transferred to the, now the third AI model. The AI model can be used any technique, as I said in the previous, ACNN or ANN or LSTM, any method. It is going to be used the user behavior model, price prediction model, and EV charging pattern model is going to be done, trained by the AI model. once it is trained by the data, then it is going to be forecast the demand. So the total demand forecast, it is total power it is going to be predict, and EV charging demand going to be forecasted, and grid impact forecast, and peak demand prediction. This data is going to be predicted by the in the demand by the AI. According to that one, it is going to be scheduled the charging. So first step is it takes the input data and then process. Once it process, it is going to be trained by the different techniques. After the training, it is going to be forecast the demand, that is it is going to be predict the demand in the future, and then accordingly it is schedule the charging. So that is the complete framework or architecture of the AI based smart charging. So what are the application of this one? Smart cities, highway charging, fleet charging, campus charging, and bus depots. So this AI-based model can be involved or implemented in these areas. So those are the applications. It may be in the smart cities, urban areas, ಹೈವೇದಲ್ಲಿ ಚಾರ್ಜಿಂಗ್ ಮಾಡೋದಾಗಿರ್ಬೋದು, ಅಥವಾ ಫ್ಲೀಟ್ ಚಾರ್ಜಿಂಗ್ ಆಗಿರ್ಬೋದು, ಆರ್ ಇನ್ ದ ಇನ್ಸ್ಟಿಟ್ಯೂಷನ್ ಆರ್ ಇನ್ ದ ಆರ್ಗನೈಸೇಷನ್ ಆರ್ ಇನ್ ಎನಿ company, that is nothing but the campus charging, or it may be a government bus stop or private bus stops. The charging demand characteristics are affect one, those are the main parameters of the demand. So the factors that affect the demand are the time, weather, holidays, or electricity price. So that means on which time they are coming, more number of vehicles are coming for the charging. So that is the effect that is going to be affect the charging demand. And we cannot predict that mean in the morning more number of vehicles are coming, or in the afternoon there are very less vehicles, or in the evening we'll get the more number of charging points, or charging more number of electric vehicles. That time cannot be predicted, generally not by the AI, but by the human beings, or in the history data you cannot predict those things. And the weather, so somewhere in the morning there may be a cloudy, or in the afternoon there may be a lot of temperature, or in the evening again it may be cloudy. So this weather prediction we cannot do manually. So that's the, again it is the factor which affects the demand. Or holidays, sometimes in the weekdays or government days, and the weekend days are the holidays that can be predicted. But some case maybe any immediate urgency, some days are some days are taken as an holidays, or linking days, maybe there may be linking days from the Thursday. If it is a working day, Saturday is also holiday, then Friday. So we cannot predict that one, that holidays. And also electricity price, so from the government the electricity price are maybe variable, so that we cannot predict. So these are the factors that affects the how much demand is going to be occur in the today, or day after tomorrow, or maybe some 1 week after. So these factors going to be affect to for the charging demand. Then user behavior analysis. So sometimes somebody, if I am the owner of my vehicle, if I go for the charging my vehicle, I may have the irrespective of the electricity price, I want to wake up my vehicle to charge. That is my perspective. If somebody else, if the Mamta has a perspective like, I have no time, I can wait for 5 hours or 6 hours, but the electricity price should be very less, at that time you charge my vehicle. So that is the depending upon the user perspective. So the user behavior is also very important. Arrival time and departure time and charging frequency, how much time during is going to be charged. Either the vehicle is going to be fully charged for one day, once in a day, or twice in a day, or once in a week, or once in a month, or once in a 2 days. That we cannot predict. That is the user behavior. That is also one of the major characteristics of the charging demand. Then we need to have the light daily load curve, morning peak, evening peak, and night charging, or weekday to week versus weekend demand. Means Friday to Monday to Friday, what is the plot? And in Saturday and Sunday, what is the plot? How many charging vehicles chargers are going to, how many vehicles are come for the charging during the weekdays and the weekend during the weekend days. And different charging patterns also, there is different charging patterns we have. So seasonal variation may be there. In the summer it may be different. In the higher maybe in the summer there are higher level of traveling, then there are more vehicles come for the charging, or in the winter higher HVDC load. So it depends, again depend upon the seasonal variation, either summer or winter or any other seasons of the year. So the finally it impacts, if there are more vehicles on the road, there are more charging demand. So in the traffic in the urban areas, there are more number of vehicles, but in the rural areas there are very less number of vehicles. The traffic is nothing but number of vehicles on the road. So if there are more vehicles, then we need more charging demand is required. And also it is depend upon the SOC influence. There is a low SOC, then large charging duration. If I am charging my vehicle when my SOC is 10%, then with remaining 90% to charge, it takes more time. If my vehicle, when I will go for the charging, my SOC is the 50%, then only 50% of charging is remaining. Then the time required to charge from 50% to the 100% is very less compared to the when the SOC level is 10% or 20%. That is also very important. ಅರ್ಥ ಆಗ್ತದೆನಾ? So that is state of charge. If my vehicle is going to be charged with the SOC of 10% or 20% or 0% or 50 or 60%, that is the important thing that also affects the charging demand. And high, as I said, fast charging demand pattern also. If a high power or short duration, if I need high power for the short duration or low power for the long duration, that is also very important. That pattern is we need to consider. Or slow charging demand pattern, lower power, long duration. Demand intensity, random arrivals, weather uncertainty, human behavior, these are the parameters, these are characteristic parameters we need to consider. And finally, what the data we need to require for the forecasting? As I said, as we said, from that architecture, historical data. In the historical data, what we need: charging sessions, energy consumed, and arrival pattern. Arrival pattern means in the morning 7 a.m. how many vehicles are coming, at 12 how many vehicles are coming, at 1 p.m. how many vehicles are coming, at 5 p.m. how many vehicles are coming, and what duration they are going to be charged, either for 1 hour or 2 hour or 3 hour. Those patterns we need to take from the historical data. Then real time data are current station occupancy, weather information, electricity tariff, and traffic conditions are the real time data. And forecast input, by knowing this data we need to forecast, we can AI can forecast expected load in the future, expected demand in the future, and expected number of electric vehicle that are going to be arrive for the charging to the charging station. As I said, there are different AI techniques for the forecasting: machine learning techniques, artificial neural network techniques, and deep learning techniques. In the machine learning techniques, the common machine learning algorithms are used. They are linear regression, decision tree, random forest, support vector machine, k nearest neighbor. These are the many algorithms that are done by the machine learning technique to forecast the charging demand. Then what are the advantages? There you can train this AI model very fast and moderate computational cost and suitable for small data sets. If the charging station are consists of only less number of charging point, so if there are less number of charging point, then less data is required. In that cases we can go for the machine learning techniques. So artificial neural networks, it has three layers. One is the input layer, hidden layers, and output layer. So here there is a very little complex algorithm compared to the previous machine learning techniques. So it can also work for both linear and non-linear relationship, high prediction accuracy, suitable for EV load forecasting. So when the complexity of the network is complexity of the algorithm is high, then we'll get the more accuracy. Then inputs, what we need: time, temperature, price, tariff, and historical demand. This data we need to feed for the ANN to get the output very accurately. Then deep learning is time series problem. EV charging demand is a time series problem. So advantages are: captures temporal dependencies, remembers fast charging patterns, widely used in smart grid forecasting. This is the method that used in the most of the cases. So applications are hour hide forecasting can be done, and day hide forecasting can be done. Station occupancy prediction also can be done. So now we are moving. We have forecasted the. We have discussed on charging demand forecasting. Once we forecast all the data, once we predicted everything in the future, what is how many vehicles are coming, at what time it's a peak demand, at what time there is a less demand, and weather condition. If we forecast, then we need accordingly we need to schedule accordingly. So this is the nothing but it scheduling, charging scheduling. So scheduling determines which electric vehicle charging first, charging power allocation, charging duration, optimal charging time, and objectives of this charging scheduling is minimize electricity cost, reduce peak demand, and improve user satisfaction. So because if I go for the charging at 10 a.m., if it is not possible to charge, so I can wait for the 30 minutes or 40 minutes depending upon my emergency. So that satisfaction will be done by using the forecasting the data. So and accordingly we can schedule that one. So types of charging scheduling. Types of charging scheduling. First come first serve, priority scheduling, smart scheduling, dynamic scheduling. So first come first curve is what happened in the normal way, that is a conventional way. How we can, if I come first for the charging, my vehicle has to charge first. If one comes from the last vehicle has to charge at the last point. So that is nothing but the first come and first serve. So that is nothing but EVs are going to be charged according to the their arrival time. So second one is the priority scheduling. Higher priority users served first. That is, if any energy emergency or any very important persons are coming, that is VIPs are coming, then we need to give the preference for the that one. But that is the priority scheduling. And smart scheduling, AI decides charging sequence and power levels. That is nothing but the smart scheduling, and allocation of the scheduling dynamically. That is nothing but the dynamic scheduling. So that is nothing but forecast charging forecasting and scheduling. Now we are moving to the last concept, that is vehicle to grid integration for grid stability. So V2G, what it mean? V2G, very important terminology in electric vehicle, that is V2G, vehicle to grid integration for grid stability. What it mean? So far we have discussed on transferring the power from the grid to the vehicle only. Howda? So how the power is going to be transferred from the grid to the charging station and charging station to the electric vehicle. There are different communication patterns. There are different charging points. There are different power levels. There are different SOCs. So all those things we have discussed. So only in the one direction, that is power is transferred from grid to the electric vehicle. If the if it is possible to transfer the power from the electric vehicle to the grid, then it is called as vehicle to grid or V2G. Vehicle to grid, that is first we have discussed on grid to vehicle. If it is a possible to transfer the power from vehicle to the grid, then it is called as vehicle to grid. That is how, when it is possible. When it is possible, when we have discussed the regenerative braking. During regenerative braking, a small amount of power energy is stored, can be stored from the wheel to the charger. That in that time motor acts as a generator. So In that cases the charge will be stored in the battery. So that battery, if that battery has a sufficient amount of energy, that can be transferred to the grid also, that is to get the stability in the grid system. So that is nothing but the vehicle to grid integration for grid stability. So it is a technology that enables electric vehicle to not only draw power from the grid but also return stored energy back to the grid when required. But it is not practically good way, because we charges the battery that is going to be charged very little amount compared to the grid, what grid going to be supply. But if it is possible, then the battery, whatever the energy stored in the battery, that can be fed back to the grid, that is nothing but the vehicle to grid. This is the structure what it has. So it shows the bidirectional, see, grid to the electric vehicle. See, grid, it may be supplying the power from the grid to the electric vehicle, or supplying the power from electric vehicle to the grid. So in the both the ways it is going to be happen, the power transfer can be happen. So that's the name, it is called as bidirectional or two directional. That's the name, V2G, vehicle to grid integration. So what are the objectives of this vehicle to grid integration? The main objectives are improving the grid stability. It is the main concern. Then supporting the renewable energy integration, reduce peak demand and generate revenue for EV owners also. Need for vehicle to grid technology, why we need, there are some challenges in the modern power system. That is, as I said, increasing of EV penetration, peak load demand, renewable energy intermittency, frequency fluctuations, and grid conjunction. So these are the challenges that what we face in the power system. So to avoid these things, we have a small room for improving the grid stability, that is done by the vehicle to grid technology. And the solution for all those challenges are the V2G solution, where EV batteries acts as a distributed energy storage system that can support the grid during the critical periods, only during the critical periods, not on the normal periods. So this is the structure of V2G system. Look into this one. You can note down the architecture. You can draw the diagram. ನೋಡಿ, ಅಟೆಂಡೆನ್ಸ್ ಇಲ್ಲ ಅಂದ್ರೆ ಪ್ರಾಬ್ಲಮ್ ಮಾಡ್ಕೊತೀರಾ, ನೆನಪಿರಲಿ. ನಿನ್ನೆ ಇವತ್ತು ಭಾಳ ಕಡಿಮೆ ಇದೆ ಅಟೆಂಡೆನ್ಸು. ನಿನ್ನೆನೂ 3-4 ಜನ ಅಷ್ಟೇ ಬಂದಿದ್ದು, ಇವತ್ತಿಬ್ಬರೇ ಇದ್ದೀರಾ. ಸುಮ್ಮನೆ ಪ್ರಾಬ್ಲಮ್ ಮಾಡ್ಕೊತೀರಾ ನೋಡಿ. 3 ತಿಂಗಳಲ್ಲಿ 10-12 ದಿನ ಕ್ಲಾಸ್ ಅಟೆಂಡ್ ಮಾಡೋಕ್ಕೆ ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಹೆಂಗೆ? ಹಾಂ, ರೆಗ್ಯುಲರ್ ಇರ್ಬೇಕು ಕ್ಲಾಸಿಗೆ. ಬಂದಿರೋದೇ M.Tech ಏನೋ ಸ್ವಲ್ಪ ಕಲಿಬೇಕಂತ ಬಂದಾಗೆ ನೀವು ಕ್ಲಾಸಿಗೆ ಅಟೆಂಡ್ ಆಗಲಿಲ್ಲ ಅಂದ್ರೆ ಹೆಂಗೆ? ತಗೊಂಡ್ರೆ ಡಯಾಗ್ರಾಮ? ಓವರ್.
ಎಸ್ ಸರ್.
ಯಾಕಪ್ಪ ಸಲ್ಮಾನ್ ಲೇಟು? ಸಲ್ಮಾನ್ ಹೋದ ಅವನಿಲ್ಲ. ಸಲ್ಮಾನ್ ಯಾಕೆ ಲೇಟು? ಸಲ್ಮಾನ್ ಸಲ್ಮಾನ್ ನಿನ್ನೆ ಕೇಳ್ತಾ ಇದೆ ಯಾಕೆ ಲೇಟು?
ಸರ್ ಆಫೀಸಿಂದ ಬರೋದು ಸ್ವಲ್ಪ.
ಕ್ಲಾಸ್ ಮುಗಿಬೇಕಾದ್ರೆ ಹಿಂಗ್ ಬಂದ್ರೆ ಹೆಂಗಪ್ಪ? ಇಯರ್ಫೋನ್ ಹಾಕೊಂಡ್ಬಿಡ್ಬೋದಲ್ಲ ಕ್ಲಾಸಿಂದ. ನೀವು ಬೈಕಲ್ಲಿ ಇದ್ರೆ
ಇಲ್ಲ
ಏನಿದ್ರೆ ಇಯರ್ಫೋನ್ ಹಾಕೊಂಡ್ಬಿಡ್ಬೋದಲ್ಲ. ನೀವು ವರ್ಕಲ್ಲಿ ಇದ್ರು ಕೂಡ ಇಯರ್ಫೋನ್ ಹಾಕೊಂಡು
ಹಾ
ಕೇಳಿಸ್ಬೋದು
ಓಕೆ.
ತಾನೆ?
ಹಾ ಸರ್.
ಮತ್ತೆ ಬಿಡಪ್ಪ, ನಾವೇನಾರು ಕ್ವಶನ್ಸ್ ಕೊಡ್ತೀವಿ, ಕೆಲವೊಂದು ಟೈಮ್ ಪ್ರಾಬ್ಲಮ್ ಕೊಟ್ಟಿರ್ತೀವಿ, ಹೇಳ್ಬೋದು ಹಿಂಗ್ ಸರ್ ಹಿಂಗ ವೆಹಿಕಲ್ ಅಲ್ಲಿ ಇದೀವಿ, ಬಸ್ಸಲ್ಲಿ ಇದೀವಿ, ಪ್ರಾಬ್ಲಮ್ ಮಾಡಕ್ ಆಗ್ತಾ ಇಲ್ಲ ಅಂತಂದು ಹೇಳಿದ್ರೆ ನೋ ಇಶ್ಯೂ. ಕ್ಲಾಸ್ ಮಾತ್ರ ಮಿಸ್ ಮಾಡ್ಕೋಬೇಡ್ರಿ. ಶಾರ್ಟೇಜ್ ಆಫ್ ಅಟೆಂಡೆನ್ಸ್ ಅದ್ರ ಪ್ರಾಬ್ಲಮ್ ನಾವು ಒಳಗಾರಾಗಲ್ಲ, ನೆನಪಿರ್ಲಿ. ಒಂದು 85% 10-12 ಕ್ಲಾಸಿಗೆ ಒಂದು 7-8 ಕ್ಲಾಸ್ ಓಕೆ, 1-2 ಮಿಸ್ ಆದ್ರೂ ಓಕೆ. ರೆಗ್ಯುಲರ್ ಆಗಿದ್ರಿ ತೊಂದರೆ ಇಲ್ಲ. ನೀವು ಇವತ್ತು ಆಚಾರು ಬಂದಿಲ್ಲ, ಅವನು ರೆಗ್ಯುಲರ್ ಆಗಿರ್ತಾನೆ, ಇವತ್ತು ಬಂದಿಲ್ಲ. ಇನ್ನು ಮಮತಾ, ಸಲ್ಮಾನ್, ಸ್ನೇಹ, ಆಚಾರ 4 ಜನ ರೆಗ್ಯುಲರ್ ಇದೀರಿ. ಇನ್ನವರು ರಂಜಿತ್ ಅಲ್ಲ, ಸಂಜಿತಾ, ಪವನ್ ಸ್ವಲ್ಪ ಬಹಳ ಇರ್ರೆಗ್ಯುಲರ್ ಇದಾರೆ ಅವರು. So this is the architecture of voltage vehicle to grid. So there is from here, from the battery management system, there is a bidirectional. Previously what we shown only unidirectional, that is power from utility grid to the energy management system, and then to the charging, and then to the battery management system, then to the electric vehicle. So now we are discussing on vehicle to grid architecture. So there is always a bidirectional, because from the battery management, if the energy is stored in the electrical package, that is monitored by the battery management system that sends the power back to the charging station and then to the energy management signal, the signal then connected to the sent to the power grid. So this is always from year to year there is a bidirectional in the case of V2G system, that is voltage to grid system. So you can call this one as a aggregator or energy management system. The third level, it is a V2G charging station and then battery management system that is inside the electric vehicle. This is completely inside the electric vehicle. The main components are what we said: utility grid in the first one, then aggregator or energy management system that monitors the signals between the power between the or communication between the grid to the charging station. Remember, this is a new word that we are using. Initially, we were using the energy management system. Here we can use the aggregator also. What it is? It is going to be communicate between the utility grid and then the charging station. So next is the communication network, then the bidirectional charger we have, then electric vehicle battery and energy management system. These are the main components we have in the V2 grid. What utility grid? So if in any case it suffers the lack of power, then it sends the information to the charging station. So if any charge stored or from the anything from the renewables or from the battery, it can be fed back to the grid system to make it stable condition. So this is the aggregator, that is the communication with the energy management system between the utility grid and the charging point. And we should have the communication network. It gives the signals between the various parts of the or various components of the charging system. Then we should have the electrical battery in the electric vehicle, where the battery is enough charged, then you can sense back to the utility grid. And again we have the energy management system and battery management system. So power can be flow from the grid to the electric vehicle or G2V, or vehicle to the grid, that is V2G. What we have discussed till now, it is a G2V. In this class what we discussed, that is vehicle to grid, that is V2G. Then working principle of V2G, that is vehicle to grid. Uh, that is first is the charging mode, that is the grid to vehicle, because without charging the battery, how it going to be supply the power from the battery to the grid. So initial stage it is should be in the charging mode, that is electric vehicle get to charge during the off peak hours from the charging point or from the charging station. Then at that point electricity prices are usually lower. So that means the main intention is uh, we need to charge our electric vehicle during the off peak period, because in the during peak period the electricity price offered is a very high price is going to be offered to the charging purpose. So we need to charge our electric vehicle during the half peak period where the electricity price is lower. So once we charge our electric vehicle or once we charge our battery during the off peak period for the lower price, then discharging mode going to be happen. So that is vehicle to grid. So EV supplies energy back to the grid during the peak demand. So for example, now I charge my vehicle in the early morning of 1 a.m or 2 p.m. At that point we know the tariff is electricity price is very less. For example, 5 rupees per kilo per unit or per kilowatt hour. So that is considered the 5 rupees. During the peak period I am going to transfer power from my battery to the grid. So during peak period the charge price is 12 rupees per kilowatt hour. So if there is an increase of 7 rupees from off period to the off peak period, then there is a gain for the customer or gain for the user, where is going to be transfer the power during the during peak period from the battery to the grid. See, remember, during the off period the supply is given taken from the grid to the charge the is vehicle for the lower price, that is nothing but the G2V, that is the charging mode or grid to voltage. During the discharging mode, that is vehicle to grid, it is going to be given back from the its charger from its battery to the grid during peak period. ಪೀಕ್ ಪೀರಿಯಡ್ ಅಲ್ಲಿ ಬ್ಯಾಟ್ರಿಯಲ್ಲಿ ಏನು ಸೇವ್ ಮಾಡ್ಕೊಂಡಿರ್ತಾರೆ, ಚಾರ್ಜ್ ಸ್ಟೋರ್ ಮಾಡ್ಕೊಂಡಿರ್ತಾರಲ್ಲ, ಆ ಪವರ್ನ ಬ್ಯಾಕ್ ಟು ದ ಗ್ರಿಡ್ ಫಾರ್ ದ ಹೈಯರ್ ಲೆವೆಲ್. ಸೊ ದಟ್ ಈಸ್ ಫಾರ್ ದ it compensates, that is the grid operator compensates the EV owners. So example, charge at night, discharge during the evening peak hours. So charge at night is a lower price for the charging, discharging the same charge during the peak hours, giving the power to for the higher rates. So it is benefited for the grid and it is benefited for the user also. So if we do these things, it services for the grid stability, that is peak shaving we discussed in the yesterday class, that is a peak shaving, reduces the maximum grid demand, and load leveling balances load variations throughout the day, frequency regulations maintains the system frequency at 50 Hz, voltage support provides reactive power support, and spinning reserve acts as a backup power during emergencies. So these are the services that is given by the V2G system: peak shaving, load leveling, frequency regulation, voltage support, spinning reserve. For example, energy available from EV fleet. This is the data available from the EV fleet. Number of electric vehicles are 500. Battery capacity is 60 kilowatt hour. Each battery has the capacity of 60 kilowatt hour. Available voltage to grid is 20%. I calculate the total energy available to the grid. Note down the problem. ಹಲೋ ಹೇಳಕ್ಕೆ ಇಲ್ಲ ಕ್ಲಾಸಲ್ಲಿದೆ. ಹಾಂ ಅದೇ ತಗೊಂಡೇ ಬರ್ತೀನಿ, ಕ್ಲಾಸ್ ಮುಗಿಸ್ಕೊಂಡು ತಗೊಂಬರ್ತೀನಿ. ಸರಿ ಮತ್ತೆ ಇಲ್ಲಿ ನೋಡಕ್ ನೋಡಿ ಮಾಡಕ್ ಮತ್ತೆ ಸರಿ. So there is simple problem. Number of electric vehicles are 500. Battery capacity of each electric vehicle is 60 kilowatt hour. Available power for voltage vehicle to grid transformation is 20%. Calculate the total energy available to the grid. So energy per electric vehicle is 60 into 0.20, that is 20%. 60 into 20% is 12 kilowatt hour. Then total energies, there are 500 electric vehicles, 12 kilowatt hour from each electric vehicle, therefore 600 kilowatt hour, that is 6 megawatt hour is available to transfer the power to the grid. See, very good amount of power can be transferred if we have the available voltage, available V2G is 20%. So if this depend upon the number of electric vehicles. If there are less number of electric vehicles, then there is less availability, power energy availability to the grid. If there are more electric vehicles, there is more energy availability to the grid. Then the benefits of the voltage to grid are improving the reliability, reducing the peak demand, better renewable utilization. So, and for this is for the grid. So for the EV owners, it can be act as a revenue, because he is going to be charge his vehicle during the off peak period time. That means charging his vehicle for the lowest price, and discharging his battery or selling his power to the grid during the peak period for the higher level. That means revenue generation, and it also reducing charging cost also. For the society, there is a less power carbon emissions and improved energy efficiency. So challenges are battery degradation. Obviously, as the days increases, the battery life is going to be reduced. Then communication security, it may be a very major issues or major challenge. And bidirectional charger cost, if you use the charger for the bidirectional, the cost of the equipment is the one of the challenge. And user participation is uncertainty. So somebody is agree for the V2G, somebody won't agree. If there are 500 owners are coming for the charging in the vehicle, then 50% may agree for the V2G. Sometimes 50% don't agree for the transfer of power from battery to the grid. That is also a challenge. And AI based energy management is role of intelligence AI in this thing, in the V2G energy management. AI can predict EV availability, charging demand, renewable generation, and electricity prices, the same four parameters what we discussed. And the techniques that can be adapted can use to train the model. Again, there are artificial neural networks, long short-term memory, reinforcement learning, and fuzzy logic controllers. So this is the end of the class. That means we cover the topics in the chapter, that is charging technologies. So I have wanted to have some activity for this session. If there are six students, regularly there are six students be there in the class. According to that one, I have prepared the activity. But now there are only uh, three students are present. So accordingly we can plan this one. uh, it's a simple task. So remember, as I said, there are different parts of the V2G. Those different parts are, see, once again we go through that one. See, once again we'll recall the whatever we have studied. See, we have studied the forecasting, scheduling, and voltage to grid. In the forecasting, in the history data, the data from the history taken, historical data, history data, we are going to forecast the future, predict the future number of vehicles available, or number of vehicles that are coming for the charging, the how much power is required, what is the grid is going to be supply, how much power grid is going to be supply, what is the peak time, what is the off peak time, what is the charging duration, and what is the SOC level of each electric vehicle. That is going to be predicted, analyzed by using the suitable AI technique. The it is going model can be trained, and accordingly we can schedule the future. So that is the forecasting and scheduling. And then there is a one more concept we have discussed, that is the vehicle to grid. Whatever we discussed in earlier days sessions, it is only from the grid to the electric vehicle. So that is supplying the power from the grid to the battery of the electric vehicle. So this is there is another concept what we discussed now, that is vehicle to grid. That means if the electric vehicle owner are interested to transfer his battery charge to the grid, there is a room for transferring the power from the grid charger to the grid, only case when if it is interested. So that is there is a again there is a the positive impact on the positiveness to the grid and the society and for the user. So because User can charge his vehicle during the off peak time for the lesser electricity price, and it can transfer his power charge energy from the battery to the grid during the peak period, where he can get the more electricity price per kilowatt hour. So that is the benefit to the user. And grid stability will be happen when there is a more demand during the peak time, that is during the 6 to 9 p.m. So grid cannot supply this much of energy to the charging. It will get the additional charge from the users, that together it will have the more power or more energy and that can be supplied during the peak period. It gives the stability for the grid. So there is a both the case we can have the advantages from the user perspective and also from the grid perspective. So that what we have. So have some activity with respect to the V2G ecosystem, that is a role play simulation. So utility grid operator and cloud EMS. So you know what is the function of each. Utility grid operator, it is going to be supply the, I will tell the function of each. First I will tell the function of each component. Later we discuss who going to be act as a different part. So there are six different, as I said, there are six different uh, parameters we have discussed here. The utility grid operator is going to be control. It's going to be give the supply from the grid to the charging station. His work is to do that one. And aggregator or cloud EMS energy management system is to communicate between grid and the charging station. That means ಯುಟಿಲಿಟಿಯಲ್ಲಿ ನಮಗೆ 50 ಕಿಲೋವ್ಯಾಟ್ ಸಪ್ಲೈ ಇದೆ ಅಂತ ಯುಟಿಲಿಟಿ ಆಪರೇಟರ್ ಹೇಳ್ತಾನೆ. ಈಗ ಈ ಅಗ್ರಿಗೇಟರ್ ಏನ್ ಮಾಡ್ತಾನೆ ಅಂದ್ರೆ ಚಾರ್ಜಿಂಗ್ ಸ್ಟೇಷನ್ ಅಲ್ಲಿ ಎಷ್ಟು ಡಿಮ್ಯಾಂಡ್ ಇದೆ, ಗ್ರಿಡ್ ಇಂದ ಎಷ್ಟು ಸಪ್ಲೈ ಬರ್ತಾ ಇದೆ ಅನ್ನೋದನ್ನ ಕಮ್ಯುನಿಕೇಟ್ ಮಾಡ್ತಾನೆ. ಅರ್ಥ ಆಗ್ತದೇನಾ? ಯುಟಿಲಿಟಿ ಗ್ರಿಡ್ ಆಪರೇಟರ್ ಏನ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ, ವಾಟ್ ಯು ವಿಲ್ ಡೂ, ಈ ವಿಲ್ ಗಿವ್ ದ ಡಾಟಾ ಹೌ ಮಚ್ ಪವರ್ is available at the grid side, whether it is a 20 kilowatt or 50 kilowatt or 60 kilowatt, how much it is available to the charging station. Grid aggregator or energy management system, what you will do is communicate between the grid and the charging station. ಚಾರ್ಜಿಂಗ್ ಸ್ಟೇಷನ್ ಅಲ್ಲಿ ಎಷ್ಟು ಡಿಮ್ಯಾಂಡ್ ಇದೆ ಅನ್ನೋದನ್ನ ಗ್ರಿಡ್ ಕಳ್ಸಿಕೊಡೋದಾಗ್ಲಿ, ಗ್ರಿಡ್ ಇಂದ ಎಷ್ಟು ಪವರ್ ಇದೆ ಅನ್ನೋದನ್ನ ಚಾರ್ಜಿಂಗ್ ಸ್ಟೇಷನ್ ಕಳ್ಸಿಕೊಡೋದಾಗ್ಲಿ, ದಿಸ್ ಕಮ್ಯುನಿಕೇಶನ್ ಬಿಟ್ವೀನ್ ದ ಗ್ರಿಡ್ ಅಂಡ್ ದ grid and the charging station will done by the aggregator. And one more will act as a V2G, that is a voltage to grid charging station. ಅಂದ್ರೆ voltage in vehicle to grid, ಅಂದ್ರೆ we are only thinking of the vehicle to grid charging station. ಆ ಚಾರ್ಜಿಂಗ್ ಸ್ಟೇಷನ್ ಆಗಿ ಒಬ್ರು ಆಕ್ಟ್ ಆಗ್ತೀರಾ, ದೆನ್ ಬ್ಯಾಟರಿ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಸಿಸ್ಟಮ್ ಅಂಡ್ ದೆನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ 1 and 2. ನೌ ವಿಲ್ ಹ್ಯಾವ್ ದಿಸ್ ಥಿಂಗ್. Now we have four students. So student 1 will act as a grid operator. Student 2 will act as a aggregator or energy management system. Student 3 will act as a charging station and a battery management system. Charging station is not from the grid to the vehicle. It is vehicle to the grid, V2G. And student 4, I will be act as the EV owner. I have the I am the user. I am taking my electric vehicle to the charging station. One will act as a grid operator. It is going to be how much power is going to be given to the charging station, that everything will be information given by the grid operator. And one more student will act as a aggregator, and third student act as a V2G charging station and battery management system. I will act as a electric owner. So we will act as a student one or grid operator. ಗ್ರಿಡ್ ಆಪರೇಟರ್ ಯಾರು ಆಕ್ಟ್ ಮಾಡ್ತೀರಾ? ನಾ ಇನ್ಫಾರ್ಮೇಶನ್ ಕೊಡ್ತಾ ಹೋಗ್ತೀನಿ, ಅದೇನು ದೊಡ್ಡ ವಿಚಾರ ಅಲ್ಲ, ಹೇಳಿ. ಯಾರು ತಗೋತೀರಾ ರೋಲ್? ಸ್ಟೂಡೆಂಟ್ ಒನ್ ರೋಲ್, ದಟ್ ಈಸ್ ಯುಟಿಲಿಟಿ ಗ್ರಿಡ್ ಆಪರೇಟರ್. ನಾ ಇನ್ಫಾರ್ಮೇಶನ್ ಕೊಡ್ತೀನಿ, ಸಿಂಪಲ್ ಇದೆ, ಅರ್ಥ ಮಾಡಿಸ್ಕೊಳ್ಲಿಕ್ಕೆ ಅಷ್ಟೇನೆ. ಇದು VTG ಅಂದ್ರೆ ಏನು ಅಂತ. ಶರ್ಮಾ,
Yes, sir. I
ನೀವು
will take
ಸ್ಟೂಡೆಂಟ್,
it, sir.
ನೀವು ವಿಲ್ ಆಕ್ಟ್ ಆಸ್ ಎ ಗ್ರಿಡ್ ಆಪರೇಟರ್. ಮಮತಾ,
Sir.
ಅಗ್ರಿಗೇಟರ್ ಸರ್.
ನೀವು ಅಗ್ರಿಗೇಟರ್ ಆಗಿ ಆಕ್ಟ್ ಮಾಡಿ. ಸ್ನೇಹ, ಸ್ನೇಹ, ಸ್ನೇಹ,
ನೋ ಸರ್, ಶಿ ಇಸ್ ನಾಟ್ ದೇರ್.
she is not there in the meeting. When she left, just I think. Now all of us are in the V2G network, that is the vehicle to grid network. You can only communicate it through with the connected components. So wherever your action you are going to be participated in that area, only you need to communicate. You cannot communicate with the rest of the thing. Remember, grid operator has to communicate with the aggregator. Aggregator has an ability to communicate with the grid operator and the charging station, and charging station has to communicate with the vehicle owner. That is the thing. So I will be taken as a third and fourth. Okay. So the initial conditions we need to have, grid load is normal, it is under normal condition. Electricity price ಎಷ್ಟಿದೆ ಅಂದರೆ ₹5 per kilowatt hour. Electric vehicle 1 SOC is 90% and electric vehicle 2 SOC is 40%, because there are two vehicles are coming for the came for the charging to the charging station. The one which has the state of charge is 90%, and the second electric vehicle has a state of charge of 40%. Departure time of EV1 is the tomorrow, and departure time of EV2 is 1 hour. Because see, departure time of EV2, even though it is 40% of state of charge, it has to leave the charging station by 1 hour, where charging SOC of vehicle 1 is 90%, he wants to leave by tomorrow. This is the initial condition you need to remember. So now I am going to tell, that is, now the time is morning 2 a.m., where renewable generation is that is wind generation is high, renewables from the wind generation is high. Electricity price drops to the 3 rupees per kilowatt hour. ಅಂದರೆ ಮಾರ್ನಿಂಗ್ ಅಲ್ಲಿ ನಮಗೆ ಬೆಳಗ್ಗೆ 2 ಗಂಟೆಯಲ್ಲಿ ಚಾರ್ಜಿಂಗ್ ಮಾಡಿಸ್ಕೊಳಕ್ ಬರೋರು ಭಾಳ ಕಡಿಮೆ, ಆ್ಯಂಡ್ ಯಾವುದೇ ಲೋಡಿಂಗ್ ಇರೋದಿಲ್ಲ ಆ ಟೈಮಲ್ಲಿ, ಲೋಡಿಂಗ್ ಯಾವುದು ಭಾಳ ಕಡಿಮೆ ಇರುತ್ತೆ. ಸೊ ರಿನ್ಯೂಬಲ್ಸಿಂದ ನಮಗೆ ಪವರ್ ಸಪ್ಲೈ ಬರ್ತಾ ಇರೋದ್ರಿಂದ, ಸೊ ಏನು ಮಾಡ್ತಾರೆ, 1 ಯೂನಿಟ್ಗೆ 1 ಕಿಲೋವಾಟ್ ಅವರ್ಗೆ 3 ರೂಪೀಸ್ ಚಾರ್ಜ್ ಮಾಡ್ತಾರೆ. ಸೊ ಈಗ 3 ರೂಪೀಸ್ ಚಾರ್ಜ್ ಮಾಡಬೇಕಾದ್ರೆ ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ 1 ಡಿಪಾರ್ಚರ್ ಚಾರ್ಜ್ SOC 90% ಇದೆ, SOC ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಿಕಲ್ 2 ಇದು 40% ಇದೆ. ಡಿಪಾರ್ಚರ್ ಟೈಮ್ ಆಫ್ E1 ಟುಮಾರೋ ಇದೆ, ಡಿಪಾರ್ಚರ್ ಟೈಮ್ ಆಫ್ EV2 ಇಸ್ 1 hour ಇದೆ. ನಾವು ಅಗ್ರಿಗೇಟರ್ ಏನ್ ಕೇಳ್ತೀರಾ ನೀವೀಗ? ಅಗ್ರಿಗೇಟರ್ ನೀವು ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ನ ಏನ್ ಕೇಳ್ತೀರಾ, ಏನಂತ ಕೇಳ್ತೀರಾ? Being an aggregator, what you will ask for the battery management system? ಅಂದ್ರೆ ನಾನೇನ್ ಹೇಳ್ತಿದ್ದೀನಿ ಅಂದ್ರೆ ಅಗ್ರಿಗೇಟರ್ ಏನ್ ಕೇಳ್ಬೇಕಂದ್ರೆ ಬ್ಯಾಟರಿ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಸಿಸ್ಟಮ್ಗೆ ವೆದರ್ ದ ಓನರ್ಸ್ ಆರ್ ರೆಡಿ ಟು ಚಾರ್ಜ್, ಬಿಕಾಸ್ ಓನರ್ ಒನ್ ಲೇಟ್ ನೈಟ್ ಚಾರ್ಜ್ ಆದ್ರೂ ಪರವಾಗಿಲ್ಲ ಅಂತ ಹೇಳ್ತಾನೆ, ಓನರ್ ಟು ಇಲ್ಲ ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಚಾರ್ಜ್ ಆಗಬೇಕು ಅಂತ ಕೇಳ್ತಾನೆ. ಸೊ ಅವಾಗ ಏನ್ ಮಾಡ್ಬೇಕು, ಸಪ್ಲೈನು ಇದೆ, ನಾರ್ಮಲ್ ಕಂಡೀಷನ್ ಇದೆ. ನಾವು BMS ಬ್ಯಾಟರಿ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಸಿಸ್ಟಮ್ ಹ್ಯಾಸ್ ಟು ಆಸ್ the aggregator has to ask the battery management system whether they are ready to charge the electric vehicle. ಯಾಕಂದ್ರೆ ಎಲ್ಲ ಸಫಿಷಿಯೆಂಟ್ ಇದೆ, ಯಾವುದೇ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ, ಲೋಡು ಮಿನಿಮಮ್ ಇದೆ, ಸಪ್ಲೈನು ಜಾಸ್ತಿ ಇದೆ, ಚಾರ್ಜ್ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಕೇಳಿದ್ನಪ್ಪ ಅಂದ್ರೆ 2 ವೆಹಿಕಲ್ ಅಟ್ ಎ ಟೈಮ್ ನ ಚಾರ್ಜ್ ಮಾಡ್ಬೋದು. ದಟ್ ಈಸ್ ವಾಟ್ ದ ಅಗ್ರಿಗೇಟರ್ ವಾಂಟ್ಸ್ ಟು ಡೂ. ನಾವು this is a normal condition. Now is going to be charged for the lesser rupees ಎಷ್ಟು ರುಪೀಸ್ ಚಾರ್ಜ್ ಮಾಡ್ಕೊಂತಿದ್ದಾನೆ, 3 rupees ಮಾಡ್ಕೊ 5 rupees ಮಾಡ್ಕೊಂತಿದ್ದಾನೆ. ನೆನಪಿರ್ಲಿ, ದಿಸ್ ಇಸ್ ದ ಆಫ್ ವಾಟ್ ಇಟ್ is going to be say, it is the off peak period. ಬೆಳಗ್ಗೆ 1 ಗಂಟೆಗೆ 2 ಗಂಟೆಗೆ ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ಅ ಹಾಫ್ ಪೀಕ್ ಪೀರಿಯಡ್, ಅಂದ್ರೆ ಯಾವುದೇ ಡಿಮ್ಯಾಂಡ್ ಜಾಸ್ತಿ ಇರೋಲ್ಲ. ಸೊ ಈ ಕ್ಯಾನ್ ಚಾರ್ಜ್ ಇಸ್ ವೆಹಿಕಲ್ ಫಾರ್ ದ ಲೆಸ್ಸರ್ ಅಮೌಂಟ್, ಅಂದ್ರೆ 5 rupeesಗೆ ಚಾರ್ಜ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ಬೋದು. ಅದನ್ನೇ ಏನ್ ಮಾಡ್ತಾನೆ, ಯೂಸ್ ಮಾಡ್ಕೊಂತಿದ್ದಾನೆ, ಅದನ್ನ 5 ಲೆಸ್ಸರ್ ರುಪೀಸ್ ಚಾರ್ಜ್ ಮಾಡ್ಕೊಂತಿದ್ದಾನೆ. ಅಟ್ ಇಮಿಡಿಯೇಟ್ಲಿ ಈಗ ಚಾರ್ಜ್ ಮಾಡ್ಕೊಂಡಾದ್ಮೇಲೆ ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಈಗ ನಾನು ಹೇಳ್ತೀನಿ, ಈಗ ದ ಟೈಮ್ ಎಷ್ಟಿದೆ, 7 ಗಂಟೆ ಇದೆ, ಸಾಯಂಕಾಲ 7 ಗಂಟೆ ಅಂತ ಹೇಳ್ತೀನಿ. 2 ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ಬಂದಿದೆ, 2 ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ಫುಲ್ ಚಾರ್ಜ್ ಮಾಡ್ಕೊಂಡಿದ್ದಾರೆ. ನೌ ದ ಟೈಮ್ ಇಸ್ 7 PM ವೇರ್ ಗ್ರಿಡ್ ಡಿಮ್ಯಾಂಡ್ ಇಸ್ ಹೈ and electricity price is 15 rupees per kilowatt hour. So both the electric vehicles are charged for the lesser rupees during off peak period at morning 2 AM. Now the scenario is changed to the peak demand. Peak demand ಯಾವಾಗ ಇರುತ್ತೆ, ಯಾವಾಗ ಡಿಮ್ಯಾಂಡ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ, 7 PM ಈವ್ನಿಂಗ್. ಈ ಟೈಮಲ್ಲಿ ಈ 7 PM ಅಲ್ಲಿ ಡಿಮ್ಯಾಂಡ್ ಜಾಸ್ತಿ ಇದೆ. ಸೊ ಈಗ ಗ್ರಿಡ್ ಆಪರೇಟರ್ ಏನ್ ಕೇಳಬೇಕು,
Check the confirmation from the aggregator whether the owners are ready to pay more amount
ವೆರಿ ಗುಡ್,
for the
that is the one case. So for the to reduce the stress on the grid, what grid operator can ask? Remember, it is a V2G.
there will be no overloading at the grid operators.
ಆಪರೇಟರ್ ಈಗ ಪೀಕ್ ಪೀರಿಯಡ್ ಇದೆ, ಪೀಕ್ ಪೀರಿಯಡ್ ಅಲ್ಲಿ ಗ್ರಿಡ್ ಮೇಲೆ ಸ್ಟ್ರೆಸ್ ಜಾಸ್ತಿ ಬೀಳುತ್ತೆ, ಗ್ರಿಡ್ ಮೇಲೆ ಸ್ಟ್ರೆಸ್ ಜಾಸ್ತಿ ಆಗಿ ಓವರ್ಲೋಡ್ ಅಂದ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಆಗೋ ಚಾನ್ಸ್ ಇರುತ್ತೆ. ಈಗ ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ V2G ಅಲ್ಲಿ ವಾಟ್ ಯು ಆರ್ ಸೇಯಿಂಗ್, ದಟ್ ಇಸ್ G2A, ಗ್ರಿಡ್ ಟು ವೆಹಿಕಲ್ ಇದ್ದ ಕರೆಕ್ಟ್ ಇದೆ. ಇನ್ ದ ವೆಹಿಕಲ್ ಟು ಗ್ರಿಡ್ ಅಲ್ಲಿ ಇದ್ದಾಗೆ ಬೈ ಡೈರೆಕ್ಷನ್ ಇರುತ್ತೆ. ಸೊ ಆಫ್ ಪೀಕ್ ಪೀರಿಯಡ್ ಅಲ್ಲಿ ಬ್ಯಾಟ್ರಿ ಚಾರ್ಜ್ ಮಾಡ್ಕೊಂಡಿದ್ದಾರೆ, ಫುಲ್ ಚಾರ್ಜ್ ಮಾಡ್ಕೊಂಡಿದ್ದಾರೆ. ಪೀಕ್ ಟೈಮ್ ಅಲ್ಲಿ ನಾವು ಈಗ ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ನ ಓನರ್ ನ ಕೇಳಬೇಕು, ಸೊ ವೆದರ್ ದೇ ಆರ್ ರೆಡಿ ಟು ಗಿವ್ ದ ಎನರ್ಜಿ ಬ್ಯಾಕ್ ಟು ದ ಗ್ರಿಡ್ ಅಂತ. ಯಾಕಂದ್ರೆ ಪೀಕ್ ಪೀರಿಯಡ್ ಅಲ್ಲಿ ಡಿಮ್ಯಾಂಡ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ದೇರ್ ಇಸ್ ಎ ಲಾಟ್ ಆಫ್ ಸ್ಟ್ರೆಸ್ ಆನ್ ದ ಗ್ರಿಡ್ ಮ್ಯಾನೇಜ್ಮೆಂಟ್, ಪವರ್ ಕಡಿಮೆ ಇರುತ್ತೆ. ಸೊ ಪವರ್ ಕಡಿಮೆ ಇರೋದ್ರಿಂದ ಪೀಕ್ ಟೈಮ್ ಅಲ್ಲಿ ಆ ಚಾರ್ಜ್ ಆಗಿರೋದು ಆಲ್ರೆಡಿ ಫುಲ್ ಚಾರ್ಜ್ ಆಗಿರುತ್ತಲ್ಲ ಬ್ಯಾಟ್ರಿಯಲ್ಲಿ, ಓನರ್ ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ಅಲ್ಲಿ ಅದನ್ನ ಕೊಡ್ತಿರೋ ಅಂತಂದು ಕೇಳ್ಬೋದು. ಸೊ ವಿ ಕ್ಯಾನ್ ನೌ ಅಗ್ರಿಗೇಟರ್ ಕ್ಯಾನ್ ನೆಗೋಷಿಯೇಟ್ ವಿತ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಓನರ್ಸ್. ಸೊ ಈ ಗ್ರಿಡ್ ಆಪರೇಟರ್ ಏನ್ ಹೇಳ್ತಾರೆ, ಗ್ರಿಡ್ ಆಪರೇಟರ್ಸ್ ಟು ಕಮ್ಯುನಿಕೇಟ್ ವಿತ್ ಓನ್ಲಿ ವಿತ್ ಅಗ್ರಿಗೇಟರ್. ಅಗ್ರಿಗೇಟರ್ ಅಷ್ಟೇ ಕೇಳ್ತಾನೆ, ನೀಡ್ 20 kW ಸಪೋರ್ಟ್ ಇಮಿಡಿಯೇಟ್ಲಿ ಅಂತ. ಅವರು ಡೈರೆಕ್ಟ್ ಆಗಿ ಗ್ರಿಡ್ ಆಪರೇಟರ್ ಇವ್ರ ಜೊತೆ ಮಾತಾಡಕ್ ಬರಲ್ಲ, ಸ್ಟೇಷನ್ ಜೊತೆ ಮಾತಾಡಕ್ ಬರಲ್ಲ, ಬಿಕಾಸ್ ಅಗ್ರಿಗೇಟರ್ ಹ್ಯಾಸ್ ದ ಕಮ್ಯುನಿಕೇಶನ್ ಬಿಟ್ವೀನ್ ದ ಗ್ರಿಡ್ ಆಪರೇಟರ್ ಅಂಡ್ ದ ಸ್ಟೇಷನ್ ಅಂಡ್ ದ ಬ್ಯಾಟರಿ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಸಿಸ್ಟಮ್. ಸೊ ನಾನು ರೂಲ್ ಕೊಟ್ಟಿದ್ದೇನೆ ಅದೇ ರೀತಿ ಇರುತ್ತೆ ಫ್ಲೋ. First, operator has to talk with the aggregator. Aggregator has to talk with the charging station. Charging station members has to talk with the electric owner. So ಈಗ ಏನು ಹೇಳ್ತೇನೆ, ಗ್ರಿಡ್ ಆಪರೇಟರ್ ಏನು ಹೇಳ್ತಾನೆ, I need 20 kilowatt emergency because it is a peak load. Now, aggregator will negotiate with the electric vehicle owners. Aggregator has a ability as a communication with the electric owners. So EV owner ಏನು ಹೇಳ್ತಾನೆ, I have the state of charge of 95%. That is almost my battery is completely full. I can discharge with a cost of 15 rupees per kilowatt hour. ಒಂದು ಅವನು ಚಾರ್ಜ್ ಮಾಡ್ಕೊಂಡಿದ್ದು 5 ಕಿಲೋವ್ಯಾಟ್, 1 ಕಿಲೋವ್ಯಾಟ್ ಅವರ್ ಮಾಡ್ಕೊಂಡಿದ್ದ. ಈಗ ಡಿಸ್ಚಾರ್ಜ್ ಮಾಡೋಕೆ ಕೇಳ್ತದಾನೆ, ಹೈ ಪ್ರೈಸ್ ಕೇಳ್ತದಾನೆ. ಆಫ್ ಪೀಕ್ ಟೈಮ್ ಅಲ್ಲ, ಹಂಗಾಗಿ ಡಿಮ್ಯಾಂಡ್ ಜಾಸ್ತಿ ಕೇಳ್ತಾನೆ. ಸೊ ಜಾಸ್ತಿ ಪ್ರೈಸ್ ಕೇಳ್ತಾನೆ. ಎಷ್ಟು ಕೇಳ್ತದಾನೆ, 50 ಕಿಲೋವ್ಯಾಟ್ ಅವರಿಗೆ ಚಾರ್ಜ್ ಅಮೌಂಟ್ ಕೇಳ್ತದಾನೆ. ಅದೇ ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ಟೂದು ಒಂದು SOC ಬರೀ 45% ಇರುತ್ತೆ. ಅಂಡ್ ಈಸ್ ನಾಟ್ ರೆಡಿ ಟು discharge his energy to the grid. He is not able. So now BMS decides maximum allocation discharge and minimum SOC constraint. So he is going to be, battery management is going to be monitors the SOC level of to the electric vehicle and how much energy can be fed back to the grid. Is it is going BMS going to be do that one. Now, so now the electric vehicle one power is going to be transferred to the grid. So that is nothing but the bidirectional. Bidirectional is from the grid to the electric vehicle is the one directional, from vehicle to the grid is the bidirectional. So for that one we need to have the bidirectional controller in the battery station. So this is how the flow of vehicle to grid going, power transfer from vehicle to the grid. So this is the flow that what we have from the vehicle to grid. So grid, then grid has to talk with the grid operator, has to talk with the aggregator, then charger, then BMS battery management system, then electric vehicle, and you can, it is going to be reverse also for the V2G. So this is the process where we have the forecasting, scheduling, and then that is V2G, that is vehicle to grid power transformer. So now we can have the, finally we can have the MCQ questions on this concept.
Sir, one doubt is there.
ಹೇಳಪ್ಪ.
Uh, Currently, do we have that V2G practically
ಅದು
in
ಇಲ್ಲ,
India, sir?
ಸದ್ಯಕ್ಕಿಲ್ಲ, ಅದು ಇಲ್ಲ,
Do we
ಈಗ
use?
ಟ್ರೆಂಡ್ ಇಲ್ಲ, ಇಲ್ಲ ಆ ರೀತಿನೇ ಇಲ್ಲ. ಯಾಕಂದ್ರೆ ಇದು ಟ್ರೆಂಡ್ ಇದು
Okay, sir.
ಯಾವಾಗ ಆಗುತ್ತೆ ಅಂದ್ರೆ ವೆನ್ ಯು ಹ್ಯಾವ್ ದ ಮೋರ್ ನಂಬರ್ ಆಫ್ ವೆಹಿಕಲ್ಸ್ ಆನ್ ದ ರೋಡ್. ಈಗ ನಮ್ಮಲ್ಲಿ ರೋಡ್ ದಾವಣಗೆರೆಯಲ್ಲಿ ವೆಹಿಕಲ್ಸ್ ಎಷ್ಟಿದೆ, ವೆರಿ ಮಿನಿಮಮ್ ಓನ್ಲಿ ಅಬೌಟ್ 10ಕ್ಕೆ 1 ಅಥವಾ 2 ಇರ್ಬೋದು ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಗಿ. ಆ 1-2ರಿಂದ ನಾವು ಗ್ರಿಡ್ಗೆ ಸಪ್ಲೈ ಬ್ಯಾಕ್ ಕೊಡಕ್ಕೆ ಅಸಾಧ್ಯ. ಸೊ ಅಂಡ್ ಆಲ್ಸೋ ಕಂಟ್ರೋಲಿಂಗ್ ಕೆಪಾಬಿಲಿಟಿ ಆ ಸ್ಟೇಷನ್ ಅಲ್ಲಿ ನಮ್ಮಲ್ಲಿ ಈಗಿನ ಅಲ್ಲೊಂದು ಇಲ್ಲೊಂದು ಚಾರ್ಜಿಂಗ್ ಸ್ಟೇಷನ್ ಆಗ್ತದೆ. ಇಟ್ ಶುಡ್ ಬಿ ಬೈ ಡೈರೆಕ್ಷನ್. ಆ ರೀತಿ ಕಂಟ್ರೋಲರ್ ಇದ್ದಾಗ ಮಾತ್ರ ಇಟ್ ಇಸ್ ಪಾಸಿಬಲ್.
Okay, sir. Thank you.
Go for these MCQ questions. First question, what is the primary purpose of vehicle to grid technology? Increase vehicle speed, enable bidirectional power flow, reduce battery size, eliminate charging stations. Second one, which component coordinates charging and discharging of multiple EVs? BMS, inverter, aggregator, transformer. Third one, load forecasting in EV systems is mainly used to predict traffic, predict future charging demand, measure battery weight, increase voltage. Which charging strategy shifts charging to off-peak hours? Peak shaving, load shifting, fast charging, opportunity charging. What information is commonly used in charging demand forecasting? Weather and historical load, paint color, tire pressure only, vehicle model only. Which standard supports EV grid communication in V2G systems? ISO 15118, HTTP, Bluetooth, HDMI. The battery management system primarily monitors road conditions, battery health and SOC, driver behavior only, grid frequency only. Peak shaving helps the grid by increasing peak demand, reducing peak demand, disconnecting EVs, stopping forecasting. Which optimization objective is common in charging scheduling? Which optimization objective is common in charging scheduling? Maximize charging cost, minimize energy cost, increase congestion, reduce communication. Dynamic load balancing ensures equal battery sizes, fair allocation of available power, same SOC for all EVs, higher tariffs. In V2G mode, power flows from grid to electric vehicle or electric vehicle to grid, solar to electric vehicle only, charger to BMS. Which forecast origin is most useful for day-ahead scheduling? Day-ahead load forecast, 10-year forecast, lifetime forecast, random estimate. Which forecast origin is most useful for day-ahead for scheduling? Day-ahead load forecast, 10-year forecast, lifetime forecast, random estimate. A bidirectional charger performs AC to DC and DC to AC conversion, mechanical braking, wireless communication only, navigation. A bidirectional charger performs AC to DC and DC to AC conversion, mechanical braking, wireless communication only, navigation. A charging scheduling can help integrate fossil fuel generators only, renewable energy sources, diesel vehicles, traffic lights. Charging scheduling can help integrate fossil fuel generators only, renewable energy sources, diesel vehicles, traffic lights. Last one. Which metric indicates availability of battery energy? SOC, RPM, GPS, VAN. V2G ಇಂಡಿಯಾದಲ್ಲಿ ಇಂಪ್ಲಿಮೆಂಟ್ ಆಗಿಲ್ಲ, ಬಟ್ ಫಾರಿನ್ ಕಂಟ್ರೀಸ್ ಅಲ್ಲಿ ಕೆಲವೊಂದು ಅಡ್ವಾನ್ಸ್ಡ್ ಕಂಟ್ರೀಸ್ ಅಲ್ಲಿ ಸ್ಮಾಲ್ ಸ್ಕೇಲ್ ಅಲ್ಲಿ ಇಂಪ್ಲಿಮೆಂಟ್ ಆಗಿದೆ.
ಸರ್.
Okay, we go with the answers. 1B, 2C, 3B, 4B, 5A, 6A, 7B, 8B, 9B, 10B, 11B, 12A, 13A, 14B, 15A. ಎಷ್ಟಾಯ್ತು? ಓಕೆ, ನೋಟ್ ಮಾಡ್ಕೊಳ್ಳಿ ಎಷ್ಟು ಆನ್ಸರ್ ಆಗಿದೆ ಅಂತಂದು. ಅಸೈನ್ಮೆಂಟ್ ಕಳಿಸಿದ್ದೆ, ನೋಡಿದ್ರಾ ಬೆಳಗ್ಗೆ? ಅಸೈನ್ಮೆಂಟ್ ಕ್ವಶನ್ಸ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಹಾಕಿದ್ದೆ.
ಸರ್ ನೋಡಿ.
ಮಮತಾ ನೋಡಿದ್ರೇನಮ್ಮ? ಹೇಗಿದೆ ಕ್ವಶನ್ಸ್? ಮಾಡಬಹುದಾ?
ಹಾಂ ಸರ್, ಓಕೆ ಮಾಡ್ಬೋದು.
ಅದ್ರ ಬಗ್ಗೆ ಡಿಸ್ಕಷನ್ ನಾವು ಬುಧವಾರ ಅಥವಾ ಗುರುವಾರ ಇಟ್ಕೊಳ್ಳೋಣ. ಮೆಸೇಜ್ ಬುಧವಾರ ಹಾಕಿದ್ದೆ, ಕ್ಲಾಸ್ ಮುಗಿದ್ರೆ ಬುಧವಾರಕ್ಕೆ, ನಾಳೆಗೆ ಮುಗಿದ್ರೆ ಬುಧವಾರ ಇಟ್ಕೊಳ್ಳೋಣ. ಇಲ್ಲ ಅಥವಾ ಮೋಸ್ಟ್ಲಿ ನಾಳೆ ನಾಡಿದ್ದು ಕ್ಲಾಸ್ ಮುಗಿಯುತ್ತೆ, ಮಂಗಳವಾರ ಬುಧವಾರ, ಗುರುವಾರ ಇಟ್ಕೊಳ್ಳೋಣ. ಜೊತೆಗೆ ಈಗ ಫಸ್ಟ್ ಏನಿದೆ ಪ್ರಾಬ್ಲಮ್ ಕೊಟ್ಟಿದ್ದಾನಲ್ಲ, ಪ್ರಾಬ್ಲಮ್ನ ನೋಡಿ ಕರೆಕ್ಟಾಗಿ ಅನಲೈಸ್ ಮಾಡ್ಕೊಂಡು ಏನು ಮಾಡ್ಬೇಕು ಅನ್ನೋದು ಅದರ ಡೀಟೇಲ್ ಆಗಿ ಬರ್ದಿದ್ದೀನಿ. ಏನು ಒಂದೇ ಸಿಂಗಲ್ ಸ್ಟೇಟ್ಮೆಂಟಲ್ಲಿ ಏನು ಬಿಟ್ಟಿಲ್ಲ. ಯಾವುದಕ್ಕೆ ಎಷ್ಟೆಷ್ಟು ಪಾರ್ಟ್ ಎ, ಪಾರ್ಟ್ ಬಿ, ಪಾರ್ಟ್ ಸಿ, ಪಾರ್ಟ್ ಡಿ ಅಂತ ಮಾಡಿಕೊಂಡು ಈಚ್ ಪಾರ್ಟಿಗೆ ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಅಲೋಕೇಟ್ ಮಾಡಿದ್ದೀನಿ ಅಂತಂದು ಇನ್ಫಾರ್ಮ್ ಕೊಟ್ಟಿದ್ದೀನಿ. ಅದರಲ್ಲಿ 20 ಮಾರ್ಕ್ಸು, 25, 30, 35 ಆ ರೀತಿ ಡಿವೈಡ್ ಮಾಡಿದ್ದೀನಿ. ಅದ್ರ ತಕ್ಕಂತೆ ಬರ್ಕೊತ ಹೋಗಿ. ಟೈಪ್ ಅಂದರೆ ಹ್ಯಾಂಡ್ ರಿಟನ್ ಅಲ್ಲ, ಯೂನಿಟ್ ಟು ರಿಪೋರ್ಟ್ ಪ್ರಿಪೇರ್ ದ ರಿಪೋರ್ಟ್. ಸೊ ಅಲ್ಲಿ 4 ದಿನದೊಳಗೆ ಎಷ್ಟಾಗುತ್ತೋ ಅಷ್ಟು ಪಾರ್ಟ್ ಎ ಮುಗಿಸ್ಬೋದು ಅನಿಸುತ್ತೆ ನನ್ನ ಪ್ರಕಾರ. ಪಾರ್ಟ್ ಎ ಕಂಪ್ಲೀಟಾಗಿ ಥೆರಿಟಿಕಲಿ ಇದೆ, ಮ್ಯಾಥಮೆಟಿಕಲ್ ಮಾಡಲಿಂಗು ಮತ್ತು ಥೆರಿಟಿಕಲ್ ಅನಾಲಿಸಿಸ್ ಇದೆ. ಯು ಕ್ಯಾನ್ ಡೂ ದಟ್ ಒನ್. ಪಾರ್ಟ್ ಬಿ, ಪಾರ್ಟ್ ಸಿ ಬಂದ್ಬಿಟ್ಟು ಮ್ಯಾಟ್ಲ್ಯಾಬ್ ಸಿಮ್ಯುಲೇಷನ್ ಇದೆ. ಪಾರ್ಟ್ ಡಿ ಬಂದ್ಬಿಟ್ಟು ರಿಪೋರ್ಟ್ ರೈಟಿಂಗ್ ಮೇಲಿರುತ್ತೆ. ಸೊ ಪಾರ್ಟ್ ಎದಲ್ಲಿ ಥಿಯರಿಟಿಕಲ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಅಥವಾ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಮಾಡಲಿಂಗ್ ಇದೆಲ್ಲ ಅದನ್ನು ಮಾಡಕ್ಕೆ ಶುರು ಮಾಡಿ. ಸೊ ಯು ವಿಲ್ ಗೆಟ್ ದ 2 weeks ಫಾರ್ ದ ಅಸೈನ್ಮೆಂಟ್ ತಾನೆ. ಅಸೈನ್ಮೆಂಟ್ 2 weeks ಸಿಗುತ್ತಾ 3 weeks ಸಿಗುತ್ತಾ?
2 weeks ಸರ್.
ಅಂದ್ರೆ
ಟೂ
ನೆಕ್ಸ್ಟ್
ವೀಕ್ಸ್
ವೀಕ್ ಸ್ಯಾಟರ್ಡೇ ಸಬ್ಮಿಟ್ ಮಾಡಬೇಕು ಅಲ್ವಾ?
ಎಸ್ ಸರ್.
ಅದ್ರ ನೆಕ್ಸ್ಟ್ ವೀಕು ಪ್ರೆಸೆಂಟೇಷನ್.
ಎಕ್ಸಾಮ್.
Okay, so start the work for the assignment, and that steps that are mentioned in the assignment itself. So in the assignment I have not mentioned which assignment is for which one, for whom na. Hello.
ಎಸ್
ಹಾ
ಸರ್.
ಸರ್. ನೇಮ್ ಹಾಕಿಲ್ಲ ಸರ್.
name ಹಾಕಿಲ್ಲ so I will
ಒನ್
mention
ಇಸ್ ಒನ್, ಎಸ್ ಟು ಇಸ್ ಟು.
according to that one only, whatever the previous faculties how they have put the same way I will put the same. There is no issue in that one. Okay, thank you.